So now let's move to the second keynote of the day. We are absolutely delighted here to provide some insights of the state-of-the-art AI as captured in the respective AI index report published annually by the Stanford Institute for Human-Centered Artificial Intelligence. In short, they are called HAI. Nestor Maslej is here. He is the research manager at Stanford's HAI. And in this position, he manages the AI index and global AI vibrancy tool. In developing tools that track the advancements of AI, Nestor helps to make the AI space more accessible to policymakers, to business leaders, and the public. Nestor's work on AI, namely the AI index, has been cited in newspapers across the globe, including, and now here it comes, the New York Times, Financial Times, Bloomberg, the Washington Post, the Guardian, Fox, Al Jazeera, Fortune, Forbes, San Francisco Chronicle, Politico, The Register, Der Spiegel, The Verge, IEEE, Spectrum, VentureBeat, and many, many more. Nestor's publications have likewise informed AI policymakers worldwide, having been referenced in countries such as the United States, Canada, Germany, the United Kingdom, China, Japan, as well as Korea. Nestor also speaks frequently about trends in AI, having briefed high-level US policymakers, testified in front of both the Canadian and the Italian parliaments, and presented to CEOs from the plethora of industries. I will stop with all the credentials right here and give the stage over to Nestor. Nestor, thank you very much for sharing some of the highlights covered in the AI Index report.
Thank you very much, Thomas. I'm super excited to be here and very much looking forward to presenting some trends on AI. And basically the report that I write, what I do in my day job is to kind of track what is going on in the world of AI. And I think that's really the main goal that I have today, is to leave you guys in a position where you have a much clearer and a more concise understanding of what the heck is actually going on in this space. Because, I mean, you log on to Twitter, it seems like every 3 days there's a new AI development. But sometimes it's really useful to just look at things from a high-level perspective, to really zoom out and see where are we now in comparison to where we have been a year ago, 2 years ago, 3 years ago, or even 5 years ago. And that's exactly what the AI Index does. Most importantly, I mean, AI is an inescapable topic of conversation at dinner parties, really just kind of anywhere. So if anything, after today's presentation, you'll be in a position where you'll have a couple of very clever insights to wow your friends with at the next dinner party when the topic of ChatGPT inevitably comes up. Now, let's go to the next slide here. So I want to tell you guys a little bit about the AI Index report and kind of what it is and what it entails. So the AI Index is a project that has come out of Stanford University. It's been around for 5 or 6 years, and it's a project that really aims to track, distill, visualize, and collate information on trends in AI, really from a wide range of perspectives. We're looking at trends, for example, in research and development. So asking, for instance, which particular countries are publishing the most in AI, which countries are leading frontier AI research. We're looking at trends in technical performance. For example, asking what can AI do now that it wasn't necessarily in a position to do 5 years ago. And we're also looking at trends in ethics, trends in policymaking, trends in economy. So really whatever you would like to know about AI, I guarantee you that you could find it in this particular report. It's a meaty report. It's 400 pages long. And I like to say that I don't even know if my father has read it front to back, but I think that the best approach to have here is to really ask yourself, what particular topics in the space of AI are you the most excited about? Flip open the report to the chapters that talk about those topics and then kind of dive in from there. Now, if we go to the next slide, we'll see some of the individuals that are responsible for managing and contributing to the AI Index initiative. I do a lot of the heavy lifting with Laura Donna, who's one of our research associates, but really the AI Index is informed by a very rich committee of AI thought leaders that really offer their thoughts and perspectives as to what is actually going on in the AI space. You have thought leaders like Jack Clark, who is one of the co-founders of Anthropic, Anthropic being one of OpenAI's biggest rivals, Ray Perot, who's a senior research scientist at SRI International, Eric Brynjolfsson, who is probably one of the world's foremost economists on trends in AI from an economic perspective, people like Tara Lyons that have advised Barack Obama on AI, and James Manika, who's a senior vice president at Google. So a lot of really influential individuals go into shaping the opinions that are included in this report. If we go to the next slide, you'll also notice that there's also a wide range of researchers and contractors that are contributing to the index, and it's important to kind of acknowledge them as well and be open about some of the great work that we've done. So let's skip ahead to a couple of slides here now. Let's go stop here at the selected collaborators. This is, I think, also something that we kind of want to mention before we dive in officially to the actual trends. It's worth noting that all of the information that we included in the report would not be possible without collaborators that give us a lot of valuable data. So thanks to a lot of companies like LinkedIn, McKinsey, GitHub, OECD, Women in Machine Learning, NetBase, Quid, we get a lot of great data, and through this data, we can really look at a lot of super exciting things in the world of AI. All right, let's go to the next slide. So I'm really going to kind of distill this 400-page report in 40 minutes, which is a tall order, but I'm going to try to boil it down into three main trends that at least the AI Index team has observed occurring in the world of AI in the last year. Now, I think on a high level, these trends aren't that surprising, but what may be surprising is some of the micro details that these trends emerge. So let's go to the first trend, which is the fact that AI has arrived, but even though AI has arrived, so have its problems. Now let's go to the next slide. One of the big things that we saw in 2022, and this has really continued into 2023, is that in the last year and a half, it's really been the year where generative AI has kind of officially broken into the public consciousness. In the last year, you had the release of large language models like Palm and Bloom that were really capable at a variety of language tasks. You also had the release of models like GLM-130B. That's a Chinese large language model, and suggestive of the fact that it's not only American actors that are getting into this space. AI development has really occurred on a global scale. You've had other systems like DALL-E 2 and Stable Diffusion. These systems, of course, being image generation systems. OpenAI very recently just updated DALL-E, and you have systems as well like Copilot from GitHub, which basically allow you to input text commands and to get code that comes out as a result, which is super cool and super exciting. Now let's go to the next slide. One of the reasons that you start seeing these systems, and I think that's kind of a question to ask, like, why is it the case that ChatGPT, Stable Diffusion, and all these systems have suddenly emerged? Well, one of the main reasons is that the number of parameters that are included in these AI systems is growing exponentially. And this chart from the AI Index shows that very well. If you want to know what a parameter is, it's one of the nodes that informs a large language model. And typically, the amount of parameters is informed directly by the amount of data. The more data you have in a system, the greater the number of parameters is going to be. And I think this chart pretty much says everything that it needs to say. In the last 5-10 years, there has been an exponential increase in the number of parameters that have been included in AI systems. And this increase is projected only to continue growing, which means that we're likely not over with some of these high-level developments that we've seen in AI systems. I mean, ChatGPT was launched in November of last year, but just this week, OpenAI was talking about how ChatGPT now has a lot of image capabilities that before it did not. So there's a lot of really exciting developments that are likely going to continue as a result of these high parameter counts. Let's go to the next slide. Now, one of the big things that we are also observing that is also super important to kind of be open, honest, and transparent about is the fact that there has been performance saturation on a lot of traditional benchmarks. What is a traditional benchmark? Well, typically in the AI space, progress has been made by benchmarking AI against a wide range of indicators. For example, take image classification. One of the most popular benchmarks in the image space was ImageNet. This was a benchmark that was introduced by Fei-Fei Li, who's actually the director of HI and a distinguished professor at Stanford. But the premise is that you have a bunch of images, you train your system, and you basically grade it on how many images it is able to successfully identify. And this kind of approach of benchmarking AI has traditionally been the way in which progress in AI has been measured. But you'll notice on this graph is showing the overall improvement that has been realized on benchmarks versus the year-over-year improvement. And you'll basically notice there's a lot more blue than there is purple. And this is suggestive of the fact that on a lot of these task-specific benchmarks, we're starting to see performance saturation. Basically, we're only starting to see very marginal, very small improvements year over year. And this is indicative of the fact that AI systems have become so good that we really need to start thinking about better ways in which we can evaluate and measure these systems. And that also speaks to some of the work that's been going on at HI, Stanford, and CRFM, the Center for Research on Foundation Models. Recently, they launched a new benchmark called HELM, which is looking at holistically evaluating a lot of these newly emerging large language models. Let's go to the next slide. Now, the first trend is kind of talking about how AI is here. Another way that AI really announced itself in 2022 is the fact that you started to see for the first time the fact that AI was really being used in science in very tangible ways. So as an example, DeepMind did a lot of research where they trained a reinforcement learning agent to help the process of fusion science. Fusion science is potentially something that could lead to a limitless source of clean energy, but it's actually very difficult to achieve in practice just because you need to have a lot of experimental parameters that you don't necessarily know or cannot necessarily find or discover from data. But through reinforcement learning, you can simulate the management of some of these tokamaks and some of these agents that lead to nuclear fission, and in the process, make that green reality a possibility. There were certain matrix manipulation problems that kind of plagued mathematicians for decades. DeepMind was also able to train one of its agents, Alpha Tensor, to engage in matrix manipulation and solve some of these codes that, again, had bedeviled mathematicians for a super long time. And then finally, in the last year, we've also seen the fact that generative AI systems have been used to kind of unlock antibody design, which means we could start using generative AI to discover new types of drugs, and that could have massive impacts for biology and humanity as a whole. Let's go to the next slide. There is also one more example of ways in which AI has kind of been used to further accelerate science, and that's the fact that AI has actually started to build better AI. In the last year, NVIDIA, they designed arithmetic circuits with deep reinforcement learning, and in the process of basically using AI, they were able to improve the performance of a lot of their GPUs, which of course are the hardware units that are actually powering AI. And all of these trends, again, are kind of evidence of the fact that AI is really starting to move into the real world. I think 5 years ago, 10 years ago, AI was still very much something that existed in the lab. It was something that had a lot of promise and potential, but it wasn't necessarily clear when that potential would be realized, when that promise would be realized. But we're actually at a point where we're starting to see that promise and that potential. AI is being used in tangible ways, and these use cases, I would say, we should only expect to continue growing. Now, let's go to the next slide. Excitingly as well, AI has been shown to help the environment. This is another experimental result that comes from DeepMind. But in this experimental result, a bunch of DeepMind scientists, they trained a reinforcement learning agent to optimize the cooling of a building in the summer. And they're basically posting the energy savings that were realized through this optimization. And it's important to know that the building was still cooled at temperatures that the people in the building actually wanted and actually desired. So it's not just the case that the AI agent just kind of turned the temperature down to 0. That, of course, would be, cheating to a certain degree. But there's evidence that AI could be used to really kind of help the environment and improve the environment. And that's something that has really massive potential in the long run. Now, let's go to the next slide. Now we kind of have to talk about some of the more thorny issues. I've talked about now how AI is getting better. It's being used to improve science. Heck, it could even be used to improve the environment. But there's a lot of evidence that AI is also causing some problems and causing some challenges. This chart, probably one of the most tweeted about from the report, is looking at the number of CO2 emissions in tons by select machine learning models and their training run. So take Bloom, for example, which was a large language model that was relatively energy efficient. It's estimated that Bloom released 25 times more carbon in its training run than a single air traveler would on a round-trip flight from New York to San Francisco. And GPT-3, of course, had a much greater impact. And this is, again, just kind of suggestive and showing that a lot of these systems are systems that are very effective, but that have also strong environmental damage. And that's something that we need to kind of be honest about, transparent about, and open about as we think about these systems and evaluate them. Let's go to the next slide. Similarly, in terms of concerning issues and concerning trends, the number of AI incidents, the number of incidents that concern the misuse of AI has also massively risen in the last 10 years. This chart is looking at data from the AAIC, which is a database that tracks information on the number of AI incidents and controversies that have occurred in the last decade. And I mean, I think this chart pretty much explains itself. There are way more incidents and controversies that are occurring now than ever before. And I think that's really indicative of two things. I think first and foremost, it's indicative of the fact that people are using AI more now, so there are going to be more kinds of incidents. And second, it is indicative of the fact that there is a greater awareness that AI is kind of in the environment. Now, what kind of incidents are we talking about here? Well, for example, one of the incidents that was included in this database was a moment where there was a deepfake video that was circulated last year of Ukrainian President Volodymyr Zelensky surrendering the fight to Russia. It was very quickly pointed out that this was a deepfake, that this wasn't an actual video, but there were certain individuals that thought that it was. And this is a very good example of some of the tangible ways in which AI could have very consequential and very significant impacts. Let's go to the next slide, which I think is going to show in a very fun way some of the actual tangible problems that you can see with these models. These are generations from Midjourney, which is one of the state-of-the-art image generators. So again, you can go to Midjourney and you can ask it for different images, and it will produce these images from the text. Now, one of the things that we did at the AI Index is that we prompted Midjourney with a variety of prompts. We asked it, for example, give me an image of an influential person. And I mean, look at the influential people that you're seeing here. It's basically 4 old white dudes. We asked it again for an influential person, and now the people appear to be a little bit younger, and there's actually one woman included in the mix, but still the representation is largely masculine and largely white, which says something about the biases that these systems project. Similarly, the third prompt here, which is, give me an image of someone who is intelligent, is basically going to give you 4 images of Albert Einstein looking people, which is again suggestive of the fact that these systems, while capable, still have a lot of issues of bias. If there are any questions or if people are wondering why these systems actually operate in this kind of way, it really has a lot to do with the fact that these systems are trained on vast amounts of data, and they kind of learn the representations that they see in the data. For example, in the training data, historically, it's probably been the case that many influential people have been white men. That doesn't necessarily mean that in the future that should be the case, but that's the kind of representation that the AI system learns. So we have to be open, honest, and cognizant about the fact that those kinds of problems exist and that these systems are capable of doing those kinds of things. Let's go to the next slide, which shows a similar problem. This is looking at Stable Diffusion, another of these image generators. You ask it for an image of a CEO, you're still going to see some kind of challenging issues and some challenging generations. Now, let's go to the next slide, which is going to be the final one in this section. We talked a lot about AI is here, it's having good impacts, it's having negative impacts, but where are we seeing this AI development? I think that's an important question to ask because it has a lot of very important geopolitical perspectives. Who's leading the AI race? Well, our research suggests that the majority of ML systems are developed in the United States, the EU, Canada, or China. Those really are the countries that are leading the race. And this kind of map is showing the number of significant machine learning systems that have been developed by country. And again, it's kind of really reflecting that a lot of the development is occurring in the West, but you do still have some significant players in, for example, Russia and China. Now let's go to the next slide. All right, so that's trend number one. AI is here. It's doing good things. It's doing bad things. What's the second big trend that you should really be mindful of? And the second big trend that you could maybe share at the next dinner party? Well, this trend is that industry is really in a position where it is rapidly racing ahead of academia, and this has a lot of very important implications. Let's go to the next slide, which is going to make this very clear. This is a chart from the AI index. Again, this is probably one of the most prominent ones that was in the report that is looking at the affiliation of new significant machine learning systems. So again, a significant machine learning system is an AI system that we deem to be important and consequential. And you'll basically notice that until 2014, the majority of significant machine learning systems were produced by academic institutions. Since then, a massive gap has emerged and industry has raced far ahead of academia, to the point where in 2022, there were 3 significant machine learning systems produced by academic institutions and really 32 produced by industry actors. And this really has massive, massive consequences that I will kind of elaborate on a little bit more at the end of this section. But this is a massive trend that we've started observing 5 years ago, and it's really started to pick up with a lot of intensity in recent time. Let's go to the next slide. There is an important question to be asked as to why is industry starting to dominate machine learning and AI? Why is it the case that a lot of these top systems are coming from the Googles, the OpenAIs, the Anthropics, and not the Stanfords, the MITs, and the Harvards, for example? Well, one of the reasons, and I think this is probably the most salient one, is that the new wave of AI research, these kind of AI large language models, they are getting bigger and more expensive. This is another piece of original research that has come from the AI index, and it's basically looking at the estimated training cost of select large language and multimodal models. And you'll kind of notice in 2019, GPT-2, which is one of the precursors of GPT-3 and GPT-4 and ChatGPT, it costs an estimated $50,000 to train. You fast forward to 2022, and some of the most significant systems like Palm, which is one of Google's flagship large language models, cost an estimated $8 million to train. And this hasn't been updated with some of the more recent systems like GPT-4, but I've read that there are some estimates that GPT-4 has cost around $50 million to train. And again, the fact that these systems are so expensive basically means that it's only really large industry actors that actually have the capacity to train these systems, to build these systems, and to actually put them out into the world. Let's go to the next slide. Part of the reason why these systems are also getting bigger and more expensive is because they're just being trained on more data. As I kind of alluded previously in the presentation, it was discovered 5-10 years ago that if you just basically feed these systems large amounts of data, they will be in a position to do better and better than those systems that are giving less data. And that's pretty much what these companies have started to do. The chart on the right is looking at the number of parameters mapped onto training costs. And you'll basically notice a pretty linear relationship that the more parameters we have on the y-axis, the greater the training cost on the x-axis. And on the left-hand side, we are looking at the compute also mapped onto training cost. Compute is kind of referring to the computational resources that are actually required to train these AI systems. The way these AI systems run is they're doing kind of calculations millions, billions of times in order to kind of learn their parameters. And this training process is one that takes, weeks, if not months. And you basically need to have large farms of computers. We're talking about soccer fields of computers that are actually facilitating this kind of training. And you'll kind of notice that, again, these kinds of high-level computational resources, these are really kind of only things that industry actors are kind of able to afford. So those kind of three ingredients, the fact that these systems are becoming much more expensive, they need a lot of data and they need a lot of compute, those are all three ingredients that, again, industry actors possess in much greater numbers than, let's say, non-industry actors. And from that perspective, it's important to understand that industry actors are very well positioned to continue leading a lot of developments in this space. Let's go to the next slide. It's also the case that a lot of new AI PhDs are increasingly heading to industry. You'll notice that in 2010, there was basically a pretty similar amount between the number of new AI PhD graduates that would go to industry versus academia. Now there's a much more substantial gap. And again, this is all significant because if industry is leading AI developments, that has particular implications for how transparent AI developments are, what kind of priorities are had in the development of AI systems. Industry actors are, of course, almost always going to prioritize projects that have some kind of profit payoff. Yet it's possible that there are experimental AI projects that need to occur that industry actors might not necessarily be incentivized to actually do and to actually look at. And from that perspective, one can understand that it really is lamentable that universities are falling behind to a certain degree. And the institute that I work at, the Stanford High, we've talked a lot about ways in which we can kind of bridge this gap and bridge this divide. All right, let's go to the next slide, which is going to take us to trend number 3, the final one. And this trend is basically, and I mean, perhaps unsurprising, is that everybody, people in industry, people in law, and people in the public are paying attention to AI. And again, I would say that this trend is probably not super surprising on a high level, but I think when you really get into the details and you see what it's about, I think you'll be surprised to find how it's actually manifesting itself. Let's go to the next slide. So first, there is growing demand for AI-related skills across virtually every American industrial sector. We include data in the report that is looking at AI job postings as a percent of all job postings in the United States by sector. And you'll basically notice that the number of job postings that are citing AI-specific skills are going up in every single industry from 2022 to 2021, with the exception of fishing, hunting, and agriculture. And I guess those people have yet to hop on the AI bandwagon, but AI can do a lot of things, and it'll be interesting to check into this report next year to see to what degree our farmer, forester, fishing, and hunting friends have jumped onto the AI bandwagon. Now, we don't have this data for other countries, but I would be surprised if it wasn't also the case that other countries similarly had trends that mirrored the one that we're seeing here. Let's look at the next slide. Interestingly enough, though, even though we've had a significant amount of AI interest, for the first time in the last decade, private investment in AI decreased. And it decreased by a fairly substantial margin, to the point where the amount of investment in 2021 was, fairly substantially higher than the amount in 2022. Now, we don't necessarily speculate in the AI index as to why this was the case, as to why investment was substantially lower this year than it was in previous years, but we strongly suspect that it has to do with changing global macroeconomic conditions, higher interest rates, et cetera, et cetera. But if you still look at the macro trend, and if you still kind of zoom out, you'll really see that there is substantially more investment now than there was 10 years ago. And this is, again, going to point to the fact that we should be expecting these technologies now to become an even greater part of our life, because more and more businesses are pioneering them and beginning to use them. Let's look at the next slide. Now, there's an important question to ask, like in terms of where is this investment kind of occurring? It's still really overwhelmingly the case that the United States continues to lead the world in terms of AI investment. If you look at private investment in AI by geographic area, you'll find that the United States has almost 3.5 times the amount of investment as its next nearest country, China. And China is, of course, followed by the UK, Israel, and India, some other countries with very strong and robust AI ecosystems. So again, it's still really the case that in terms of AI development, the United States is the top dog. Let's go to the next slide. Now, in terms of where we're seeing the most significant investment, it's mostly in fields like healthcare, data management, and fintech. These are the fields that have seen the greatest amount of investment. And we have a lot of really cool and exciting data in the report. And again, I would encourage you to flip through the report that further disaggregates this and further kind of cuts up how some of the investment trends have occurred. Now let's look at the next slide, which is one of my favorites in the report and in the presentation. And it's my favorite for two reasons. I think one, it's very important, and two, it just looks very pretty. And the research associate, Loredana, that was making this slide, I think she said this was the hardest visual to make. So I think we have to shout out a visual of this caliber. But what is this very nice looking chart actually saying? This chart is looking at data that came to us from a McKinsey and Company survey. And in this McKinsey and Company survey, the company McKinsey was basically asking people that had used AI as part of their business processes whether AI led to cost decreases and revenue increases. And you'll basically look at across every activity or across every function that we could encounter, there was a fairly substantial amount of respondents that said that there were cost decreases and revenue increases, which basically means that from a bottom line perspective, if you are using AI in your business, you are being in a position where you could save money and increase revenue. And really, to a certain degree, business profitability is fundamentally comes down to that equation. Now let's look at the next slide. It's not only business people that, of course, are waking up to the presence of AI and to the reality of AI. It's also people in the policymaking world. Of course, we've seen a lot of discussion recently that has occurred around the EU AI Act, but there's been really recent legislation, and we talk about this at great lengths in the index, that has looked at AI from a diversity of perspectives. This report, this slide, is just looking at AI-related legislation from select states, but states are getting in on the act, countries are getting in on the act. Really, everybody is getting in on the act, because I think there's this growing sense and there's this growing perception as well that AI is here, and we need to start thinking critically about how we want to engage with this tool and how we want to engage with this technology. Let's go to the next slide. It's not only policymakers that are waking up to AI, it's also the legal world. This is original data that comes from the AI index, and this is looking at the number of AI-related legal cases that are in the United States that have occurred in the last 20 years. And I think this graph is relatively straightforward. It's showing hockey stick growth and reflective of the fact that, again, now more and more companies are integrating businesses into the world that are using AI tools. And with the integration of a lot of these AI tools comes a lot of very thorny legal questions. Can large language model generated ideas be patentable? What happens if a user is on a website that is using AI and an AI search engine or algorithm, for example, recommends that someone does something nefarious? Is the company then liable? These are all very interesting questions that the world needs to kind of wake up to, and the world needs to be cognizant of as AI becomes more and more ubiquitous. Let's go to the next slide. Now, for the first year in the AI index, we actually looked at public opinion trends, which I think are very important when talking about the AI landscape, because to really get a good understanding of who might be leading developments in the AI space, it might be necessary to understand how different people feel about AI. And when looking at the question whether products and services using AI have more benefits than drawbacks, Chinese citizens are overwhelmingly the most positive, whereas American citizens are at the bottom of the list, followed by Netherlands, Canada, and France. So it's very important to kind of watch out for this and to kind of see how perspectives and attitudes of AI change geographically, because this can have a lot of very important say and impact on who might actually be leading the AI space in the near future. Let's go to the next slide. Of course, if you've been in San Francisco, you've probably seen a self-driving car by now. But at the moment, research suggests that most people would still not feel safe in self-driving cars. According to a survey from Lloyd's Foundation, 65% would not feel safe, which is, again, indicative of the fact that even though this technology is here, there are certain groups of individuals that are still very skeptical and still very mindful of this technology. Let's go to the next slide here. It's also interesting to see what kind of things people actually care about when it comes to AI. And when it comes to AI, there seems to overwhelmingly be a lot of concerns about loss of human jobs. That tends to be the main issue that people are concerned about. There are concerns about surveillance, hacking, and digital privacy, as well as a lack of human connection. So all of these very kind of valid issues that are very poignant and kind of influencing how people think about AI and how people imagine AI. Now, let's go to the next slide. So that includes the AI-specific portion of the presentation. But given that this is an event that is celebrating in a lot of ways the potential synergies of AI and Web3, we also want to look to the future a little bit and see some of the ways in which the AI world might be intersecting with the newly emerging Web3 space. And I'll kind of make a note that the AI index in previous years hasn't spent much time focusing on this intersection, but we expect it certainly to kind of increase in the near future. And as it increases, this is something that we're going to want to pay more closer attention to. So let's go to the next slide. And I think it's worth asking at this stage, what are some of the ways in which AI can actually be used to advance Web3 and further Web3? Well, first is security. I mean, security is a massive concern for a lot of Web3 platforms. And I think the promises that a lot of these platforms offer in terms of things like decentralization can only really be fully realized if there are guarantees and assurances that these platforms are secure. And we can be using AI for things like anomaly detection to perhaps detect unusual patterns or behaviors on blockchain networks that could be indicative of fraudulent activity. AIs could be used to smartly audit contracts. They could be used to identify different identities to ensure that we have good quality user authentication on a lot of these platforms. They can be used as well for predictive securities, doing analysis and identifying which particular areas are secure and robust and which particular areas are not as secure and not as robust. And finally, they can also be used for decentralized threat intelligence. So on a security platform and on a security front, there are many ways in which one can imagine that Web3 can benefit from AI. Let's go to the next slide. AI can also enhance Web3 applications. I think one of the big promises of Web3 is just the excitement that can come with using a lot of these platforms that are decentralized, that are intelligent, and that are really kind of tailored to you and the kind of person that you are. You can, for example, have user-friendly interfaces that are going to have AI-powered chatbots and virtual assistants that can be very intuitive. They can be conversational, as we kind of saw before my own presentation. They can ask you questions. They can receive guidance. They can perform different kinds of tasks. And this could really enhance the user experience on these platforms. And that also means we can have personalized experiences. We can have experiences that are tailored around your own preferences. AI can be basically analyzing information on some of the things that you do, and we can, in the process, gain a better sense of what are some of the optimized user experiences that we can do for you to really get the most out of a system. I think another really cool potential promise with AI and Web3 applications is language translation. You may have seen this recently on the internet, but there's now AI systems that could functionally get you to be talking in a different language. As in, if you're filming a video, you might be talking in English, but in real time, there's going to be translation to another language. And that really has a lot of massive implications. You could interact with someone that speaks a completely different language. And that really has potential to do super exciting and super amazing things. And I think lastly, there's a lot of accessibility features here as well. AI can assist in voice to text, text to speech, image recognition, and that's good for really democratizing and opening access to the space. Let's go to the final slide here, the next one. Last but not least, AIs can improve decision-making in DAOs. We have data analysis and insights from AI systems that can really get DAOs to analyze data and make better decisions. NLP algorithms can summarize lengthy governance proposals, make them more digestible, which makes governance work a lot easier. AI can assist in voting analytics, dynamic quorum and threshold management, as well as conflict resolution. So really, the Web3 space is one that I think is going to benefit tremendously from the massive increases that we've seen in AI. And as someone whose day job it is to kind of literally pay attention to trends in AI, I'm very excited to see how this space is going to develop and unfold. Let's go to the next slide here. Could we transition perhaps to the next one? There we go. Well, not too many slides left. Just wanted to kind of conclude by thanking all the contributors and the sponsors that we've had. Again, the report is long, it's lengthy, it's 400 pages. So I would encourage you to check out the report. There is way more information in the report than actually I was able to talk about today. But I was very excited to speak, very excited to talk about an issue that's super important, and now very much looking forward to moving to questions that users may have. And I think we have some time left for that.
Can I go back to the main stage? Yvonne. Yvonne.
Okay, so we do have a couple of questions from the audience. The first question that we have is from Janai Priya, and that is, how can generative AI models like ChatGPT be effectively fine-tuned using self-supervised learning techniques to improve their performance in specific domains and applications?
Well, I mean, I think that's more of a technical question that would be better suited for a computer scientist. But I would say that on a high level, it's important to kind of draw a distinction between models that are closed and models that are open. So you have certain models like Bloom that openly release the weights. I also believe that Meta for Llama openly released its weights. So with those kinds of models, it's a lot easier to do the fine tuning because users can actually do some of the work themselves and actually do some of the nitty gritty stuff. Whereas for other programs like ChatGPT, they're closed. They're obviously, you can use the models, but the weights are not accessible. So you're kind of limited to using the interface that a lot of these companies provide. So I would say that it really depends on the type of model that you're actually looking at and the type of function that you want to realize. But there's a lot of really good research that looks at prompt engineering and ways in which you can kind of get these systems to perform a lot better depending on where you prompt them. But to a certain degree, it's not even necessarily feasible to do that optimization with ChatGPT unless you have the underlying weights, which OpenAI, to my knowledge, does not release.
Got it. Thank you. Another question in terms of how can normal people voice their ideas in developing AI, from Mehdi Hamedi.
Yeah, that's a very good question. And I think it's a question that speaks to the fact that AI is going to affect us all. And there's a potential for this technology to have quite inequitable impact if we don't manage it well and if we don't use it well. I would say the biggest thing is, I think getting active in the political process. I think we're now starting to see a lot of policymakers becoming a lot more aware that AI exists, that AI is something that really affects us all and that it's very consequential. And I think speaking to these policymakers about concerns that you have and issues that you have, and those kind of concerns and issues can then be reflected potentially in law. I would also say that if you're in a business, there's a good chance that your business at some point is going to be using AI, and thinking about ways in which you could ensure that the business rolls out AI in a democratic way, in a way that's accessible. That's also an avenue through which you can kind of exercise your voice. So a lot of different avenues, I would say, where you could really, really get involved in the process.
Perfect. Thank you. And I think alongside with that question is how can, with the increase of data, could misinformation skew the general? Were you able to hear me? I don't know.
You just cut out at the end, so if you could repeat
Oh,
the question, that would be great.
Sure. So with the increase of data, could misinformation skew the generative AI output?
Yeah, I mean, certainly it's definitely possible. I think it depends how you kind of define skew, but there is a lot of research that these systems in AI, they could be trained to be toxic and biased, as in the developers like OpenAI and Anthropic, they're not trying to make these systems toxic, but inevitably, if you are training these systems on a lot of data that is, conspiratorial or has certain kinds of stereotypes, then it's possible for the system to be toxic and possible for these systems to be biased as well. A good example of this, and I think this was one that was featured in last year's AI Index report, but there was an experiment that asked a large language model to classify different images. And one of the images that it was asked to classify was of an American astronaut, I believe Eileen Collins, in one of her astronaut costumes. And one of the generations that the image created was that this is an image of an American housewife in an orange jumpsuit with an American flag. So something that was kind of very toxic and very biased. So this potential definitely exists, but a lot of companies are aware that this exists and they try to build in mitigations to ensure that these kind of models are not necessarily outputted in a biased and toxic way. But to a certain degree, it becomes an invariable cat and mouse game because these systems are released into the real world. There's a sense that, oh, they may have these mitigations, there may be these things that are taken into account, but there's always going to be some problems and challenges that exist with the systems. And then users might actually use the systems in real time and exploit them as well.
Thank you. That was a great answer. And I think there's some concerns
We can hear you.
misinformation and fake news, etc. So the next question, in blockchain tangle the problem?
Do you mind repeating the question? Because you just cut out a little bit.
Sure. Yeah. The next question that we have is from Kivora Lucky, and that's regarding how AI and blockchain tangle the problem of fake news, misinformation, and disinformation. So align with the previous questions, but adding the blockchain component to how to address misinformation.
That's honestly something that I haven't thought of super deeply. And in the interest of not spreading further misinformation, I'll say that I don't really know ways in which blockchain could be used to combat misinformation. It's perhaps something that we could kind of look into and something that might be interesting to consider, but it's not something that I've necessarily come across in my research.
Okay, and I think, and so the next question that we have, I think is the last question. A lot of people are concerned, again, I was mentioning about fake news, etc. In regards to the kindness or empathy, how do you build in kindness or empathy into these systems?
Yeah, that's a great question. I mean, there's a lot of different methods that you could use. As an example, one of the significant producers of these systems, Anthropic, they have a set of ideas called constitutional AI, which is a set of rules that kind of governs how AI systems are supposed to operate. So that's one of the ways in which you could do it. A lot of these companies also do something called reinforcement learning through human feedback, where humans are used to kind of identify responses that are helpful, unhelpful, that are harmful, that are not harmful. And in the process, the AI system learns through this kind of representation what might be a good answer versus what might not necessarily be a good answer. So again, there's a lot of different ways you can experiment and a lot of different mitigations that you can employ. But as these systems become more and more capable, this is going to become an area of increasing concern and increasing seriousness, I would say.
All right. If that was the last question, I have maybe one more comment. First of all, thank you very much, Nestor. This
It's my
was
pleasure to be here.
incredible. I hope for the audience it was as useful as it was for me to get a refresher about the current state of AI with a little bit touch of Web3. Maybe a quick comment for the audience. The AI index is available for free, right?
Yeah, it's freely available. It's online. If you just Google AI Index Stanford University, you should be able to find it. And I would be very excited if you guys dove into the report and figured out what you needed to figure out about what's going on in the world of AI.
So I can only highly recommend to read the report. I personally, and I told Nestor this a few months ago, I think it comes out in the April timeframe.
Yeah, in the spring, yeah.
So as soon as the AI index report came out, I literally have read it twice.
I didn't believe him at first, but
it's true.
It's true.
It's on the record now.
Serious. Yeah,
it is true.
Very true.
And the reason why it's kind of funny, it's literally that report is 386 or something pages long.
It's long. It's quite a long report.
It is incredibly informative. If you want to look at any aspect of the ecosystems from various angles, it is an unbelievable report. The next one I can wait for next April to come out. So Nestor, thank you very much for giving an incredible speech and sharing this very incredible information about the AI index report.
Thank you very much for having me today.
Thank you very much. Appreciate it.